Kia ora. Welcome to this video lesson on two-way tables. In this lesson, we are going to be talking about problems using a two-way table like this that involve the words randomly chosen item. So for starters, a two-way table, which is sometimes called a contingency table, is a way of displaying outcomes for two different events. Let's look at this first example. Data below shows the items in three people's wardrobes, Amon, Ricardo, and Terry. So what's the probability that a randomly chosen item is a shirt? So what these problems want you to do is, based on the item we're talking about, find that row or column and use that to determine the probability. So the probability that a randomly chosen item is a shirt. And again, when we see randomly chosen item, that means that the bottom part of the fraction, in other words, the denominator of the probability, will be the total number of items, okay? So randomly chosen item is a shirt. Well, how many shirts are there? 16 out of 31. So that would be the probability a randomly chosen item is a shirt. Let's try another one. What's the probability that a randomly chosen item was a tie from Terry? Okay, well, ties can be either from Amon, Ricardo, or Terry. We're looking for a tie from Terry. So that means it's only going to be the Terry column and the ties. So there are 5 ties that are Terry's out of a total of 9. So the probability that a randomly chosen item was a tie from Terry would be 5 out of 9. And lastly, what's the probability that a randomly chosen item was not from Terry? Well, Terry has 9 items, so that's not including these. These are the items from the others. So 13 and 9, 22 over 31. Okay, let's see if we have time to try one more. We've got some parts in here. What's the probability that a randomly selected student has at least one sister but no brothers? So when we see randomly selected item or randomly selected student with no other conditions, that means it's going to be out of 63. So randomly selected student has at least one sister but no brothers. So these have sisters but no brothers. That's going to be 19 over 63. Let's see how we did there. 19 over 63. Yep, we got that one. And the second part, what's the probability that a randomly selected student has at least one brother? So when we see randomly selected student, that's going to be telling us that the denominator of our fraction will be out of everybody. So let's see now. Has at least one brother. A randomly selected student has at least one brother. Well, that's this column here. So no brothers 31, but yes brothers, there are 32. So it should be 32 over 63. Well done. Okay, any patai, please do send them my way. As always, thanks for watching. Mauri mahi, mauri ora, kakiteano.